Well, let's get started now. And so I'd like to introduce our three speakers. We have Melissa Higgins. She's an earth scientist in the NASA Astromaterials Research and Exploration, that's ARES, division at NASA Johnson Space Center. Melissa trains astronauts in earth sciences, so maybe she's trained the astronauts that are up there now. That's a pretty cool job to have, that have been selected for flight. Geolocates astronaut photography that has come down from the International Space Station and is involved in daily mission operations with the current crew on the ISS. Amy Jagge is a geographic information scientist at the Johnson Space Center. Her research includes specialization in geographic information, extraterrestrial perspectives of the Earth that is useful to current and future NASA missions. Paige Graff, I think I missed a line there, but that's okay. Paige Graff is a science engagement and communications specialist within the ARES division at the NASA Johnson Space Center. Her current work involves sharing, communicating, and actively involving students, teachers, and the public with science facilitated within NASA's ARES division and NASA's Science Mission Directorate. All three of them also work with us occasionally on the CosmoQuest program, and so we're absolutely delighted to welcome Paige, Amy, and Melissa to tonight's webinar.
Great, thanks, Brian. I guess I'm going to share my presentation here, so let me know if we don't see it. I think we should, but here we go. So if you can't see that, Brian, let us know, and we'll get ourselves started here.
It looks great, Paige. Go for it.
Okay, so
great. So like Brian mentioned, I'm Melissa Higgins. I'm going to be giving this talk with Paige and Amy. We are with the Earth Science and Remote Sensing Unit based here at the NASA Johnson Space Center in Houston. And we deal with the astronauts on the International Space Station and focus on Earth science topics. So let's just dig right in. So right now we have approximately 1,000 satellites currently orbiting Earth, and they're studying everything from the ocean up to the atmospherics. And our group in particular deals with one of these satellites, the International Space Station, and all of the suite of remote sensors and crew commanded sensors that are on the ISS. So I know this is a very busy slide, but this is what's currently on ISS as far as sensors is concerned, looking down at the Earth. We've got both remote sensors that are commanded by the ground, and we also have sensors inside the station that are crew commanded. So for example, we've got CATS here in the bottom right. That stands for Cloud Aerosol Transport System. And this guy sits outside on the external ISS truss, and it takes imagery of, or I'm sorry, it uses the LiDAR system to look down at the atmosphere and look at particulates in the atmosphere. And it is a ground commanded sensor. Inside the station, but also ground commanded, is EarthCam. And you can see that guy right here. This was founded by the first American woman in space, Sally Ride. And it is commanded by the ground as well. Groups of students can command to take pictures of the Earth for any of their investigations. And then something that is internal but is managed by the crew on ISS is CEO, which is Crew Earth Observations. That's actually what our group does with the International Space Station. And we task the crew to take images of the Earth for research. So astronauts have been looking and studying the Earth for decades now, ever since the 1960s, back at Mercury, Gemini, and Apollo, and the famous Apollo 10 Earthrise that you can see here, and the Earth kind of coming up over the horizon of the moon. So we have been involved with crew members on manned space flights since the early shuttle days. We've been tasking the crew to take imagery of the Earth and studying, and we kind of transitioned into the International Space Station and have been around since the beginning of the space station program. So there's a lot of reasons why astronaut photography is very unique, and there are a lot of benefits of astronaut photography that are different from any other sensor going around the Earth right now. For example, because of the orbital path of ISS, we are able to see the same areas but in different lights. So for instance, we're looking at the Italian Peninsula here. We can see it during the day when the sun is directly overhead, all the way to when the sun is on the opposite side of the Earth and we're looking at the city lights of the peninsula itself. We also, because of our vantage point, we get to see different look angles because we have great windows like the cupola, for example. The cupola offers a 180-degree view of the Earth. And so we're able to see everything looking straight nadir, which is essentially what all satellites are seeing that are orbiting the Earth, and all the way up to the Earth limb looking out at the horizon of space, which you can kind of see here in the top left of the image. This is really great for looking at aerosols in the atmosphere because you can see through the thick of the atmosphere itself, or it's also really great for looking at, for instance, maybe hurricane eyes, where you can see stereo imagery kind of approaching the hurricane eye wall, looking straight down into the eye wall, and then as you fly away and providing that imagery to researchers. On the International Space Station, we have several different camera lenses that offer everything from a fisheye 8mm view of the Earth all the way down to a 1200 or a 1600mm lens view. So basically what this means is that we can see everything from an entire country in one image all the way down to maybe airplanes on a tarmac. So we have various fields of view that the astronauts can just slip on and off a new lens and see a different perspective. So all of these reasons are why astronaut photography would at the very least be a great complement to other satellite data taken from space. For instance, if something is a hyperspectral sensor taken from space, all of these different areas that I just talked about would be a great complement to that satellite imagery, so you can have a complete data set to work with. One of the great things that we get to do, and that Brian mentioned, is mission operations. So each mission, or increment as we call it here, we create a site list, and it's anything from tens to hundreds of different sites around the world that we build into our site list, and it's built from different resources, and I'll explain those in just one second. But we use those in our daily mission operations. So for example, one of our sources is we accept requests from the public, either scientific investigators like principal investigators, or from classrooms. So for example, this is a picture that the crew took for a classroom of Viedma Glacier, and it's part of the Expedition Earth and Beyond program that Paige actually manages. And the students wanted to look at how the glacier was looking today and compare it with imagery taken in the past to see if there's been any retreat at all of the glacier. Also, before crew members fly, we give them the opportunity to give us a site list, essentially, that we can notify them of once they get up into space. So they maybe give us 10 to 15 ground sites that they'd really like to take pictures of, say, for instance, their hometown or a military base that they were stationed at. And we can notify them when they're going to be passing over and do all the grunt work for them. So all they have to do is go to the window and take a picture. We also get the pleasure of working with very big public affair events. So for instance, our group got to be involved in the Live from Space National Geographic show a couple of years ago. And during this broadcast, it was live video footage that the astronauts were holding some cameras and doing interviews and looking down at the Earth. And our job was to sit on console, tell the host of the show what they're looking at on the Earth, where the ISS is at a given time, and so on. So that was a lot of fun. We also got to provide the Earth scenes for the IMAX film, A Beautiful Planet, that was released just last year. And that was a great experience as well. And finally, one other thing that helps build our site list up is the International Disaster Charter. This is where we help, so to say, when a natural disaster hits an area, say for instance, flooding from a major hurricane, for example, or tornadoes or an earthquake hit an area and they need to assess the damage, or for instance here you can see wildfires near Sydney, Australia, and they need to see an aerial view of exactly what we're working with as far as damage is concerned. So we take real-time photographs of these natural disaster areas, and as you can see here, we were able to see the exact area that the fires were spreading to, how thick the smoke was in areas, how the smoke was traveling, and they were able to use this imagery along with other sensors imagery to send help where needed. So it's a great complement there. So once we have all these sites that I just mentioned, the tens to hundreds of ground sites, we plot them in our daily mission operations software. So this is what you're seeing here is a little screen capture of the ISS. We plot the orbit tracks, which is this yellow line that you can see across your screen. And we also plot all of our ground targets, which is this blue box you can see here. We plot all those on, we look at the sun elevation angle, and we look at the weather over that site. And we basically determine, can the crew members see that particular site from space when they fly over? If they can, we include it in our CEO target list up to the crew, and we send them one every single day. So the bottom right of your screen here is an example of one of the targets that we send to them. We give them, and it might be hard to see, I'm sorry, so I'm just gonna tell you what we're looking at here. We give them the time down to the second that they're gonna fly over. We give them the camera lens that we need them to use to take the picture we need. We give them a little blurb of information, just kind of telling them what to look for, where to look for it, and why we're asking you for this target. And then we give them a couple of pictures to kind of lead them in, because if you think about it, they're flying at 17,500 miles per hour at 250 miles up. It's gonna be really challenging. They have about 90 seconds total to find this target, take pictures, and finish the target. So we need to provide as much information as we can in our target list to help guide them down. So once we do that, they put the camera lens on that we ask, they look out the window, snap a few pictures, cross their fingers they got it, and they'll downlink that imagery to us. Now they take imagery for our target or for our payload, and they also take imagery just in general at their leisure. So all of that imagery is downlinked, which is a fancy term for using communication satellites to get it down here. And we host all of it in our database, which I'll talk about in just a minute. We also get to be involved in astronaut training. As soon as the astronaut is selected for their mission, they have about a 2-year stint of nonstop training for their mission. And we're involved with that. We get to teach them everything Earth science related. So we can tell them what they should expect to see when they look out the window, how to identify things like geography, geology, things like that, and whatever information we can give them so that they are finding it easier to find our targets. So one of the things that we train on is human impacts. So for example, here's a picture of Three Gorges Dam. We've got a researcher that actually works here on site, and she is looking at the impact of the dam. So this dam is located on Yangtze River in China, and it was recently built and fully functional in 2012. So what this researcher is looking at is everything that's happening downriver from the dam. So how is this affecting the river health, and is there any kind of sediment buildup? So she wants to see pictures over time to see the health of the river. We also train in glaciers. So this is a great picture of the Patagonian ice fields, and we're looking at the glaciers all along the outskirts of the ice fields. So just to give you a sense of scale, here is the Viedma Glacier I just mentioned a second ago that we took imagery for the Expedition Earth and Beyond group. Another glacier that we've been watching is the Uppsala Glacier, and this glacier, we have imagery taken in 2012 or 2002 and 2013. Comparing the two, we saw that that glacier has retreated 2 miles. So the imagery that we take over time of these glaciers really helps us analyze the health of the glaciers and to see the patterns in the glaciers themselves. We train in urban areas and natural hazards around those urban areas. One of our researchers is looking at Chicago at night, which is right there in the middle of the picture at the base of Lake Michigan. And he's looking at light pollution in Chicago. So he's asking for just a couple of pictures and then he'll be done. And he's going to use that in complement with other sensor data to do his research. We got a few other areas that we train and we study. For instance, planetary analogs, comparing features on Earth that are similar to those on other planets. Deltas and coasts, we're looking at how the coast looks over time, the deltas look over time, and then we have great before pictures in case any kind of natural disaster does hit and there's a massive flood or whatever the case, we have before pictures to help with that. We look at impact craters, geography, aerosols like smog, haze, and smoke. And I'm going to hand it over to Amy.
So thank you. All right, so in next slide, one more. In addition to crew Earth observations, the Earth Science Remote Sensing Unit also has a background in geographic information science and remote sensing. So geographic information science is the science of storing, manipulating, analyzing, and visualizing geospatial data. Geospatial data is defined as data that contains geographic positioning information, such as latitude and longitude, which we represent as XY data, or height data, represented as Z data. Remote sensing is the science of acquiring information about an object or a feature from afar. Remote sensing instruments can take many forms, including but not limited to sun synchronous, orbiting satellites, LiDAR, or handheld digital cameras. Next slide, please. So let's look at some of the work that we do with GIS and remote sensing. As Melissa mentioned earlier, in partnership with the International Disaster Charter and the United States Geological Survey, the Crew Earth Observation Payload tasked astronauts on board the International Space Station to acquire imagery of international disaster-activated areas that are being affected by man-made or natural disasters. So once the imagery has been acquired and reviewed and received, our group will post-process the imagery so that the data delivered to the USGS is in a science-ready data format. In order to create these science-ready data products, we have to transform this normal digital image into geospatial data. Next slide. Oh, I'm sorry. Nope, not next slide. I'm sorry. So using GIS tools such as GeoRef, which is what you see on the screen right now, this is a screenshot of the tool we use. This tool is developed by the GeoCam Ames team in collaboration with our group, the Earth Science Remote Sensing Unit. We will process astronaut photography by georeferencing the photograph to a Google Earth base map and assign a photo center point. Georeferencing is the process of aligning geographic data to a known coordinate system so that each pixel within the image has a coordinate system assigned to it, or geographic positioning information. And the reason that we do this is so that once the image is georeferenced, it can be analyzed, visualized, or analyzed and visualized or queried with other geographic data. So once the image is georeferenced and we have assigned a center point, then we can label geographic feature names, upload that to our SSEO database, and then also deliver it to the USGS. So using these GIS tools, we're able to enhance the data quality of the data that we deliver to the international disaster community, and we're also able to enhance our database with high-level data products. Next slide. Our group is also involved in planetary analog missions. So planetary analog missions allows scientists and engineers to prepare for future space exploration by conducting missions in terrestrial environments that simulate the surface or environment of other planetary bodies such as Mars. The most recent mission our group was involved in was NASA's Extreme Environment Mission Operations, also known as NEMO. NEMO is an analog mission that simulates extreme space environments so that scientists, engineers, crew members, and mission operations personnel can test tools, technology, methods, and procedures that will better prepare us for future space exploration. Our group's involvement in this was to create a 2D or 3D image mosaic of the seafloor of the Carpenter Basin. Here you can see the 3D model of the seafloor. And the reason we created this mosaic was, one, to test the software and to also develop data acquisition methods and procedures. But the main purpose was also to test the potential for the mosaic to enhance traverse planning for extravehicular activities, EVAs, and daily science operations. Next slide, please. along with planetary analog missions and image processing for the International Disaster Charter, NASA also has a regional remote sensing endeavor to use satellite imagery and real-time sensor measurements to research localized climate change in the Clear Lake region in southeastern Texas. So what you see here is our technology the technology that we currently use for these real-time sensor measurements. Drifter at the top of the screen is a low-cost, versatile environmental buoy system, and it was created by NASA's Applied Science and Technology Project Office out of the Stennis Space Center, and the purpose was to enable public participation in NASA scientific research. Drifter is currently in the Armand Bayou, and it uses different sensors to collect in situ water quality measurements for parameters such as water temperature, salinity, hydraulic conductivity. The Drifter data is available at the Drifter Twitter feed, or you can also get it on our website, Earth Science Remote Sensing. Next slide, please. So simultaneous to NASA's regional remote sensing, NASA has tasked each center to assess its vulnerabilities to climate change, and it tasked its climate change adaptation science and investigators working group to deliver climate change expertise to facility managers and planners. Each center had its own working group. So the NASA Johnson Space Center, their working group developed a historical data set that would be used by scientists to quantify and monitor change over time. So it includes historical remotely sensed imagery of the Johnson Space Center, but also of the Houston-Galveston area. And the data that is included in the data set are remotely sensed imagery acquired from multispectral and hyperspectral sun-synchronous orbiting satellites, airborne LiDAR, airborne sensors, and astronaut photography, which is acquired using digital handheld cameras. Using web-based GIS, our team is delivering these science-ready, remotely sensed data sets to the public. So here you can see what our portal homepage looks like. It's not live yet, it's still being worked on, but what you'll be able to see here is the different web mapping applications where you can access and visualize the data. So the public will eventually have the ability to view the CASI data sets, apply basic analysis, and download data into a GIS software of their choice. And the next slide will show what a web mapping application might look like. So here's an example of a web mapping application. You can see the very high resolution imagery of the Johnson Space Center. On the left, you can see a vegetation enhanced image. On the right, there is a indice applied, a normalized difference vegetation indice. You will also be able to look at the different layers of the imagery you would like to display, and there'll be some basic analysis to it. But once you are visualizing this in the web map, you'll also be able to download the data into a GIS software of your choice and conduct your own analysis. Next slide. So through the presentation, we've mentioned our free, easily accessible, and robust astronaut photography data set and how it can be used in a variety of scientific research, such as change detection analysis. So this remotely sensed data set can be used to create land cover and land use classification maps for cities, forests, wetlands, and many more geographic locations of interest. So looking at land use and land cover maps over a long period of time allows scientists to quantify change that has occurred in a specific area. Using remote sensing and GIS techniques, scientists can use this daytime image of Houston that you currently see on the screen, acquired in 1985. This nighttime imagery, the nighttime imagery acquired, there we go, in 2002. And you can generate classification maps that will help monitor population growth or light pollution, for example. Here's an example of a classification map. I created it very quickly, but it gives you an idea of how you can visualize land use and land cover within a city that you'd like to look at and start quantifying change within your region. Okay. Now pass it back over to Melissa.
Sorry, we had to unmute real quick. Thank you, Amy. All right.
Try that now.
Okay. So now that you've learned about all this really great information that we gather and we store here at NASA Johnson Space Center, where are you going to find it? Well, we've got a few different things for you. First, the Gateway to Astronaut Photography of Earth. This is the largest official database of astronaut photography looking down at the Earth, everything ranging from Mercury and Gemini in the 1960s to what was taken on ISS today, and of course we'll be storing future data as well. Besides that, we've got a few other things on our website. We have a collections page, so if you're interested in something like volcanoes, for example, or impact craters, we have collections built specifically for you there that you can go and browse a little bit more. We've got time-lapse videos, which you've already seen one, but I'm going to show you one more near the end. The tool to request new imagery that we talked about, building our sites up so that we can request those of the crew. That ability is here, and a lot of other really cool tools and data is stored here on this website. Then we also have the Earth Science and Remote Sensing Unit website. It's kind of a broader view of all Earth science going on the International Space Station. So you can see all of the past missions that were on ISS, all the current missions, and all the future missions that we've coming down the pike. So a lot of information here, and then you can go learn more about them if it kind of piques your interest. The regional remote sensing that Amy was talking about, we have all that data stored here as well. So we've got all of the drifter data that we've been storing for a while is available here. More information about Cassie, what Amy was talking about a second ago, and a lot of other cool projects going on. And then International Disaster Charter, I mentioned those with the wildfires over Sydney. We've got all of our collections built there that we've been collecting data for the past several years for the International Disaster Charter community. So lots of great information stored there as well. Once a week, we pick a really great picture taken by astronauts from space, usually of the current mission, but sometimes we have to go back a little bit further. And we will write a little article about it. Usually it's a couple paragraphs. It's easy to read. It's built for middle school level reading, so it's very informational, but it's high level, so it's easy to understand. We give those to our colleagues over at Earth Observatory based at Goddard Space Flight Center, and they post those on their website once a week. They also have articles written on other sensors from space or just ground collection data that they post on here as well that you can read about. And if you're more of an interactive learner like I am, then there is a layer on Google Earth, a NASA layer. So you can kind of fly around the Earth here, and you can go to an area that might interest you and see if there's a little NASA meatball. They're teeny tiny, but this guy here, you can kind of see it. And our articles are posted there, so you can read more about them directly inside of Google Earth interface. So those are the 4 different arenas that you can find all of our data that we make publicly available, free to download, easy to access. So now that we've talked about all that technical stuff, I just wanted to show you guys some really pretty pictures taken from space. So I think this is one that speaks near and dear to Paige's heart because she loves Hawaii. But it's a really cool picture because of the sun glint that you can see here in the upper right portion of the image. Sun glint, from a more technical and scientific perspective, is really great for looking at water features, especially over land. So if you want to see the river running through a land, it's especially accentuated by sun glints. You can see if it's flooded or if it's kind of lower in water or whatever the case is, but it's a really handy tool. But it's also a very pretty picture of the Hawaiian Islands. I knew we were talking to the Night Sky Network, so I wanted to throw an aurora picture in there for you guys. This one, the ISS was over the Atlantic Ocean, or the Pacific Ocean rather, I'm sorry, looking northeast toward Canada. And I think this is one of my favorite aurora pictures because you can see the aurora kind of hugging the North Pole. So it really shows you the structure from up in space. So it's a pretty cool picture. So we were talking before also about the detail you can see all the way down to the airplanes on the tarmac with the 1600 or further back. So this is more of a detailed shot looking at Dubai. So we can see the streets, these kind of orange yellow colors here. You can see the downtown area over here in the middle left. And you can even see the man-made Palm Island over here, nice and bright over the water. So that's pretty cool detail. But then you can also get a really big context shot. So now we're looking at the Bahamas. This is probably one of the most requested areas by the crew members because they really love to look at the beautiful light blue colors against the dark, dark blue Atlantic Ocean. So one of the features that's kind of neat here is the tongue of the ocean. It's kind of this little jut of deep, deep water that goes into the coral reefs of the Bahamas. So if you can kind of think about it without getting too freaked out, these ripply things here are coral reefs, so very shallow water. And then immediately, right after, right here in the tongue of the ocean, it just juts down into Atlantic Ocean. I can only imagine how scary that would be to be over in that area, but it's beautiful to look at from space, and we get a lot of images from this area because they love to take pictures of it. Another picture just for you guys. This is part of a time-lapse sequence, actually, so that's why it's a little blurry, but they adjusted the camera settings so that you can see the Milky Way, you can see the stars, you can see awesome features above the Earth limb. And then below the Earth limb here, we've got Morocco area. These orange, yellow lights are city lights, and then these white lights are actually bolts of lightning. So during this time lapse in particular, there are actually a lot of bolts of lightning as we fly over Africa. There must have just been a bunch of thunderstorms that day. This picture is especially telling because we've got India on our left, we've got China and the Tibetan Plateau on our right, and right up the middle of your screen here, we've got the Himalayas. I even found Everest for you guys right down here in the bottom middle of your picture. So the cool thing about this picture is the Tibetan Plateau over here on the right is so high. The Himalayas are so high, but the ground here in India is so low. So all of the smog that's coming off of just how densely populated over here in India is, it has only the Himalayas to jut up against, and then it comes back down. So all this standing area, or all this standing haze right here is smog. So I'm sure it's not very fun to breathe, but the air looks very clear on this side. So back down to details, here's the Sahara Desert. So you can see individual sand dunes. One of our scientists here likes to study the migration patterns of sand dunes, and he's actually working with somebody, I'm not sure where they're based, but he's working with somebody to watch the migration patterns of sand dunes. And you can see so many different patterns and so many different shapes of these sand dunes from space. I forget what these are called.
I think they're star dunes.
Star dunes, thank you. I'm definitely not the expert on that, but star dunes, you've got so many different types of dunes that you can see from space. So the more detailed shots like this are very telling. This is probably one of my favorite images because I'm a meteorologist by education. So this is a picture of a tropical cyclone at night. So the cyclone itself is being illuminated by the moon. And I'm sure your attention went straight to the lightning bolt. This was a very serendipitous shot because they got a picture of the lightning. And since it was over water, if you look really closely, you can actually see the blue of the ocean underneath inside of the eye wall. So it was just the right place at the right time, but a really cool picture. Just one more because I'm a meteorologist. So this is we were talking before about the detail, and we were also talking before about the different viewing angles, how you can see as the ISS approaches cyclone eyes, looks straight down into cyclone eyes, and then flies away. We've actually got a payload that we're working with to study this exact feature. But because they used a long lens here, maybe around an 800 or so, they got to see the structure of the eye wall. So you can actually see the depth of the eye wall because they were looking more obliquely as opposed to looking straight down. You get to see just how tall that eye wall is, how calm it is in the inside, and how fierce and intense it is right on the outside of the eye wall. A lot of really great data here. And then one more picture, they had a really cool setup in the cupola where they were using a fisheye lens and some kind of mirrored device, and maybe you guys are better with pictures than I am, but this was a really cool shot because they got almost the entire globe in one image through the cupola. So we thought this was a pretty neat shot to show you guys as well. And then I think we have a time-lapse video next. Are we going to show that right now?
I think so, if you want to.
So this is an example. This next slide is going to be an example of the time lapses that we were just speaking about, that you can go to the Gateway of Astronaut Photography of Earth and go look at all of the time lapses that we've been storing over time. But we hope you guys enjoy it. There's sound. Next, I'm going to turn it over to Paige.
Awesome. Well, thank you, Melissa. And I don't know about all of you, but I've seen that video time and time again, and it still gives me chills. It is so inspiring. The work that our group, our Earth Science and Remote Sensing folks do here is so absolutely awesome. And the imagery that comes out of it, we wanted to spend a couple of minutes to just share with you a little bit about how you can use astronaut imagery in activities that you may do, whether they're in formal and or in informal venues. So there's two things we at least wanted to share with you. One is on the left, blue marble matches, and the other is an activity that's up and coming called Image Detective 2.0. So I want to start with blue marble matches, because this is an activity that really enables you to utilize this astronaut photography of Earth to be able to help your participants or audiences learn about comparative planetology. So this whole idea of getting people to look at different features on Earth and then be able to apply what they're learning to better understand other planetary worlds. I'm just going to take a few minutes to talk about this. Now, anytime I'm working with audiences, whether it's in a formal classroom or an informal setting, I always try to introduce the imagery to participants. And any image within this activity that you're looking at of Earth was taken by an astronaut either on the International Space Station or the Space Shuttle. So what you can see here, there are 8 images, 1 through 4 on the top, 5 through 8 on the bottom. And I usually try to cut up these images so they're small little images that people can kind of manipulate and move around. But to introduce this imagery to participants, one way to do it is to describe an image and have the participants try to figure out which image you're describing. So for those of you that might be working in a chat window, let's see if you'll play along with me. I'm going to describe an image, either image 1 through 4 or 5 through 8. You tell me in the chat window which image you think I'm describing. So here's my description. This image has a circular feature in the center. That circular feature is rather bumpy in texture. The picture itself is somewhat orangish in color. And if you look closely around the middle bumpy circular feature, you may see a faint circular feature. And I'm seeing for the majority of you, it looks like I have image number 3, and this is in fact image number 3 that I was identifying or that I was describing. Now, in introducing this imagery to participants, you'll notice that I didn't use any technical terms. I just described what I was seeing, and I used terms to help people like mentioning the shape, mentioning texture, mentioning anything like an adjective that can be used to help a person identify an image. This just sort of allows people to really get into the images without being afraid that they may not know what they're actually looking at. So you can have participants describe images to others and you can kind of play a game, but it's all about kind of building some curiosity. Now, the second thing I oftentimes do is with that same set of images, let folks know that, okay, these images are actually representing 4 different geologic processes: wind processes, water processes, volcanic processes, and impact processes. And then I'll ask them to pair the images according to what process they represent. And I give them a hint, because you certainly want to get them started on the right foot. So I might set up again on a table little labels: impact, volcanic, water, and wind. I let them know images 3 and 8 are part of the impact process, and then allow them to work with each other so they can kind of look at these images and decide which ones belong in which categories. And they're usually able to do that very successfully. The one thing I will notice and I will mention is that 9 times out of 10, the images on the right in the wind category, they kind of make people scratch their heads and say, well, what are those things? Really, is that wind related? I was thinking they might have been something else. And that's exactly what we want our participants to do. Get them thinking and curious so that they can learn more. And by the time they finish this activity, they'll know what those features are and they'll be able to defend what feature they can actually name it. So it is really, really engaging. But they kind of, now this third part here, if you're in a formal classroom, it's sometimes helpful to have the students formally go through developing identification criteria to name features that exist within each of these geologic processes. That in an outreach setting, that's way too long. So there is a way, and it's shown here, where I kind of use, in a sense, a little bit of a game board. So this sort of whitish area here where I label it, here we're going to look at Earth. We've got the 4 processes and other, which we're going to ignore for now because all the images they would work with fall into one of these 4 categories. And they're given a set of images as well as keywords and the name of a feature so they can try to match things up. So given these cards and given these little feature and keyword cards, in the end, your participants, all totally hands-on, come up with their own identification of, oh, these 3 images are features created by the wind or water or volcanic activity or impact craters. Now, it is so important that participants kind of get this sense of you can look at any image of Earth, For example, in the water section, that very first channel image, there are keywords that you can't quite see at this little screen here, but these keywords become key descriptors that they can apply to any other image of Earth and apply that to when they're looking at other planetary worlds. So those keywords and descriptors are so important to have them at least first think about Earth before they actually move on to other worlds like Mars. So in this kind of instance, again, when I do this at an outreach type of activity, I keep the Earth cards and the Earth game board up so they can use it as a reference. And then I have these images of Mars where they can cut them up and you have 8 different images, same kind of game board, and it's up to the participants to place the image in its respective category. Now, the great fun part of this is usually they're like, oh, well, okay, I think this looks like that Earth image, so I'm going to put it in volcanic area. And they kind of try to do a visual match, which is great. But to really enhance some of their scientific practice skills, by giving them a little bit of this blue card, and this is just a little example, and asking them to, whether you do it in writing or have them do it verbally, to have them justify using those keywords that they got from the Earth images, have them use those keywords to justify what type of feature they think they're seeing and what is helping them justify that classification. And we even actually ask them to put in a level of confidence, because if their confidence level is low and they're like, oh, I'm not really so sure, then you can help maybe talk them through, again, helping them to kind of understand and gain some real scientific practices that scientists may use themselves. So you can do this with Mars, again, referencing what you know about Earth to applying it to Mars. You can even do Pluto. Some of these images of Pluto become really quite interesting for audiences, because the first thing they see is, oh, well, I can identify craters, but what is some of this other stuff? That's when it really sort of leads to discussion of not just the features, but missions in which these images were taken. And in this case, the other category certainly comes into play, because there are some things that participants are like, you know what, this doesn't match anything else, so I'm going to put it in the other category. So this is really engaging by cutting up these cards and allowing them to sort of place them into a game board little setup. It's really an effective way to use Earth, especially our astronaut imagery, for planetary comparisons. And we do have images of Mars, we have images of Earth's moon, of Venus, Mercury, moons of Jupiter, and even Pluto, and we'll probably build some others in the future. So this is one of the 2 activities I wanted to mention to you as far as some of our resources. The other, if I go in the right direction, is one of our newest items that we're getting ready to release sometime in the very near future. And this is Image Detective 2.0. Now this is, as I think Brian mentioned earlier, this is a CosmoQuest citizen science project. It will be the newest addition to their set of science projects. And this is a NASA-funded grant under the Astronomical Society of the Pacific. This entire Image Detective 2.0 is building on things that we have actually worked on in the past, but it is utilizing all of our astronaut photography, where we're looking for the public to help us label and identify features in images, as well as help us identify the center point of this large database of imagery that we have. So this just will give you a little smattering of what is involved in Image Detective 2.0. The first thing is you get an option to scroll through some images and select an image you might want to start working with. Once you select an image, then you're given a variety of tasks to complete. One of those tasks is to look at the image and decide what percentage of the image is covered by clouds. So you have a little slider bar that'll allow you to sort of make some choices. And there's a little question mark off to the side of these questions so that you can get some reference information to help you answer the question to the best of your ability. So we have cloud coverage. Another task that we'll want citizen scientists to do is to select features that are visible in the image. So you might be asked, as you can see here, do you see any of these water features? And it lists a number of features. Well, now let's say you have a user or a person in your audience and they're like, I don't know what a delta is. Well, that little question mark, if they click on it, it will bring up a little screen that will sort of help you understand what a delta is, as well as give you 2 or 3 thumbnail views of what a delta might look like from space. And again, if they can kind of match those characteristics, similar to blue marble matches, from these little thumbnail images, that will help them identify the features that they might see in a particular image. Now, another task that we can actually have you go through, or that we really want you to go through, it's a little challenging, but is to identify the center point of an image on Earth. Now, this again is somewhat challenging because you're looking at a piece of Earth, you don't know what size of, or how much of the Earth that image is covering, but this will take you through the process. So an image like this, you might say, yes, I want to try to locate it. Couple of tips for you to think about so that when you're using this tool, you might be more successful or really feel good about what you're doing. The first sort of map that it will open up to is actually the point at which the ISS, the International Space Station, was estimated to be above that point of Earth when that image was taken. Now, keep in mind, as Melissa told you many times, these crew members are holding the camera and they have a 180-degree view through that cupola, so you don't know exactly which direction they were pointing. But we do know the estimated point of where the ISS was. So that's the first thing. So using Google Maps, just a couple of tips, you can zoom in or out of the map to try to find some land where you can try to match up what you're seeing in the photo with features on the map. So it's a bit of pattern recognition, some pattern matching. What might you do next? Well, here's a couple of other tips. You've got these sliders that I have outlined in sort of a yellow box here. Transparency, rotation, and scale. Once you think you have an idea of where that you think this image is in this area, you can use those sliders to help you kind of line things up. And you're looking to line up size, the location, and the orientation. So you'll notice the image on the left, you can't really see the map behind the image. So using the transparency tool, you can kind of identify, ooh, I think I noticed this shape in the actual image. So that's where, again, using these little slider tools can be helpful. And then our final little tip is, once you've used those transparency, rotation, and scale slider tools to really match things up, and again, you can kind of like fine tune it so you know you're right on point. We'll ask you to actually identify the center point of that image, click you found it, and then you have actually completed somewhat of a challenging task. This, I am a New Yorker, I am originally from New York, so I picked this image because I knew I could be successful at it. But there's a lot of other images that really people want to challenge themselves and find out and really improve their own geography skills. So again, Image Detective 2.0, it's the newest of the CosmoQuest items, and it'll be coming out soon. And actually, I believe next week there'll be a GTTP presentation in which some other activities highlighting Image Detective will be available for you to be able to learn about. So stay tuned for that. I think Teresa is a part of that as well.
Yeah,
so,
and we'll be mentioning that in just a couple of minutes here when we get done. So
awesome.
Yeah.
So just to sort of wrap up, these two little activities we just briefly thought we'd share with you. We think you might find them useful in your uses, again, whether formal or informal venues. Blue Marble Matches, I have the website where you can retrieve that below it. And for Image Detective 2.0, we are in beta testing phase right now. If you want to get involved in the beta testing, you can email beta@cosmoquest.org and they can get you set up. So we're really excited about that. And we're really excited and very passionate about our astronaut photography as a whole. So with that, we thank you. I know there's questions that Brian's going to pose to us. So we'll answer as many questions as we can get to. But for now, thanks for listening to our presentation. Brian, we'll turn it back to you.
Yeah, well, thank you very much. This is great. And I know I can, personally, I've used blue marble matches with teachers in workshops, and they really, really love it. And so it's a great tool. And I like the adaptations that you've had for using with the amateur astronomers. If you have a star party planned and it rains, you got to have something to do. So this would be a great thing. Well, we've got time for a couple of questions here. And so we've got one question. I thought that this one was quite interesting. Do the astronauts have preset recommended apertures and shutter speeds before they go up to compensate for the motion of the ISS, or do they basically meter it for themselves?
That's a great question. If you don't mind, I'll take that one. So with this guy here, about the, oh, sorry. Okay.
They just made the question go away.
Oh, sorry.
Okay, no, it's okay. I think I remember. For the most part, crew members like to set their own camera settings when they take imagery, so they'll set it on the manual setting, but sometimes when they don't feel very up to the challenge, they'll set it on automatic and let it kind of adjust as needed. We have a great group here that trains the astronauts in everything photo TV related, and so they do a lot of training right before flight that kind of gives them a little bit of information on this is what you need to compensate for ISS speed, or this is what you want if you want one of those really great time lapses, kind of where we saw Morocco was blurry. That's because the settings were optimized for time lapses instead of actual just one single frame acquisition. So for the most part, yes, they do adjust those themselves, but sometimes they just set it on automatic and let it go.
Okay, and let's do one more question, and then because we're a little bit past the top of the hour, I thought that this one is interesting. Do they receive any disruption to their photography due to any coronal mass ejections?
To my knowledge, no, they do not. We have experienced some communication issues with the International Space Station, which will affect the uplink and downlink of imagery. But as far as interfering with them taking imagery, not to my knowledge. No, there's been no interruption.
Okay, and let's do one more question. We'll call this the last question. This came in. I know that it's the International Space Station, and so do you train astronauts from other countries?
Oh, that's a good one. We do not. No, we primarily train NASA astronauts. If somebody from ESA requests something special, we will accommodate that. But for the most part, ESA and Roscosmos, which is based in Russia, they do their own earth science training. They do their own training regimen in general. So they handle everything over in their native country, and we handle everything on the NASA side over here. I'm trying to go quickly so we can get more questions if you want to.
Yeah. Well, I think that we probably should wrap it up here. And so this is great. Yes.
If I could just jump in one second, because I know someone had asked about the eclipse in August, and if
that's a good question.
Imagery can be acquired from there. And I know Melissa has an answer for that as well.
I do.
Okay.
Yeah. I'm sorry to steal the show here, but I'm answering all the questions.
No, this is good.
Well, we've got a project going, and I think there's a website, but I don't know it offhand. A lot of the NASA centers are actually working on the big solar eclipse event, and I know that our group in particular has been monitoring the ISS orbit tracks to see if they're going to be in an ideal location to take imagery. Right now, we are trying to task them to take imagery looking down at the Earth to see if maybe we can see the shadow of the eclipse on the Earth. We've seen that before, especially over cloud tops. We've seen a big shadow over white cloud tops, so it stands out like a sore thumb. But we also are trying to ship a filter up so that the crew members can actually look through the filter toward the sun. If you go on our website, Gateway to Astronaut Photography of Earth, we've got a collection called The Transit of Venus, where they looked up at the sun during the transit, and they actually got Venus going across the sun. So we're trying to see something very similar to that if we can fly the filter, but if nothing else, we're going to spot the eclipse on the ground during the event.
Great. Well, thank you so much. And this is absolutely fantastic. And that's all for now. I wish we had more time, but You'll be able to find this webinar along with many others on the Night Sky Network website, and this one will be under the Outreach Resources section. Each webinar is also posted on the Night Sky Network YouTube channel. You should be able to find it there by the end of the week. To learn more about how to incorporate ISS imagery into your outreach, please join us for a webinar featuring an activity from the CosmoQuest program on Tuesday. There's several that we're working on. And so I think that I just posted this on, maybe I didn't. Let's see. I tried to post this. It's not posting. Now I can't even post anything to the chat for some reason. I'll try to do that in just a second. And so we're gonna, on Tuesday morning, April 25th at 8 a.m. And so I'm gonna try to get the link up here in the chat window. We will also post it on the NSN website. And now for our drawing, I'm going to turn this over to David, and he's going to run through the drawing, and I'm going to try to put that link up here into the chat window.
Okay. So for this last, for our prize for these wonderful posters, we're going to do the usual guess a number sort of deal. I'm going to try a little bit of trivia again. Hopefully this isn't too weird. So there's an asteroid that is, I believe, flying by Earth right now. I'm not sure if it's already made its closest pass or not. If the first person, and you don't need the full name of the asteroid, not the first person, the fifth person to enter in the last two digits, which is a number of the asteroid's name, gets these prizes. We got some folks.
It's 3, 4, 5.
It's David Tabor, because of the asteroid name. The full name is 2014. Should have 2014 or 2015. 2014 JO25. And so David Tabor, you have won 5 beautiful exoplanet vintage posters. So awesome.
Yeah, David, if you could send your contact information and your mailing information to us in an email at nightskyinfo@astrosociety.org, and we would appreciate that so that we can get that sent out to you. So also mark your calendars. Well, for this coming Tuesday, I managed to finally get the link up into the chat window, so you could copy that, save that for Tuesday morning, and we will also post that so everyone can find it on the Night Sky Network webpage. But also mark your calendars for our next monthly webinar on Wednesday, May 17th, when we will welcome Kevin Hussey from NASA's Jet Propulsion Laboratory, who will share with us the NASA visualization tool, NASA's Eyes, and how you can use it in your outreach. That's a really cool one. It's I think there's an app. I haven't played with it, but Paige, maybe you and your group are familiar with that as well. All these cool visualization tools to bring space to our fingertips, so to speak. So keep looking up, and we'll see you next week. And good night, everyone.
Hi, thank you.
Thank you.